If we think about a lot of the 3D shapes we've come across, particularly the prisms, but a few of the others as well, it is quite clear that these 3D shapes have been made from taking some 2D shapes and joining them together. A cube, for example, like this one, is clearly 6 individual squares that have been stuck together. Now, in theory, what we could do is we could take this cube and we could flatten it. Flatten it back into the squares that it was made from, and make effectively a template. This cube, in fact, has been made from a template. And if we were to remove that template, we could flatten this shape out into the squares that it has come from. How many faces does a cube have? Well, it has 6, and we can flatten this out into 1, 2, 3, 4, 5, 6 squares that join together. And when we were to fold these squares back up, we would be able to make, once again, the cube. This flat template, this joining together of 2D shapes to give us a 3D shape when we were to fold them up, this template is called a net. Now, there isn't an awful lot we are likely to have to do with nets, but it's worth being aware of them. It's also worth being aware that for lots of shapes, there are lots of different ways we can join these together. This is one particular way of coming up with a template to make a cube, but there are many others as well. Now, it is possible, although not necessarily that likely, that we might have to draw the net of a particular shape. In particular, the 4 prisms that we've looked at, that's the cube, the cuboid, the triangular prism, and the cylinder. There's also other uses for this idea of nets and being able to split things into the 2D shapes that they are made from. But let's have a quick look at drawing the net of, say, a triangular prism. If we think about a triangular prism and we're asked to draw the net, well, it's usually helpful when drawing a net to start with the base. So the base of a triangular prism, that's the bit that would sit on a table, say, if we put it in front of us. The base of a triangular prism is a rectangle. We could even label that with the base if we wanted, just to make it really clear to us. And then on either end, here, left and right, we would have triangles coming off it. And those triangles are what would fold up to give us the triangular ends of the prism. On the sides then, we're going to have the sides of the triangular prism. They will fold up to make the sloping sides to meet the edges of the triangle, 2 rectangles there. And this, for example, would fold up to make a triangular prism. Like so. If we were to look at this cuboid, 5 centimeters along here, 3 along here, and 4 in height. If we were to look at this from different points of view, we would see different things. Now, we could recognize that this is a 3D object because we can see a face flat on the page, we can see that it has a top, and we can see that it has something on this right-hand side here. If, however, we were to look at it from front on, then there is technically nothing there in what we can see telling us that this is a 3D object. All we can actually see here is a rectangle of 5 centimeters in width and 4 centimeters in height. Now, we know it's 3D, but that's only because we know it's 3D. Imagine if you were looking at this with no prior information, not having seen that this is a cuboid that I've tilted. And imagine if you were looking at this in a completely blank, white, perhaps void. So there's no light, no shadow, nothing to tell us that it is a 3D object. All we would see is this rectangle 5 centimeters wide and 4 centimeters in height. Now, if I make a quick sketch of that rectangle and label it up, it's 5 centimeters across and 4 centimeters in height. What I have done there is I have drawn what I would see when looking at the shape from this direction. I have drawn what is called the front elevation. i.e. the view when you look at it front on. Practically speaking, if we are transferring information from a diagram of a 3D object into a sketch of the front elevation, if we're asked to draw the front elevation of a shape, it's the face that's flat on the page, the face that's drawn as a proper 2D shape at the front there. There are other angles that we could look at as well. If we take our cuboid again, there is our front elevation, but maybe instead this time we want to look at it from side on. And once again, side on, all we are seeing really is another rectangle, 3 centimeters across here and 4 centimeters in height. If we're looking at it from the side, we are once again just seeing a rectangle, because we don't have any contextual information from what we are seeing to tell us that it's a 3D object. And so we could sketch that view from the side as well. We would have another rectangle, and this rectangle will be 3 centimeters across the bottom and 4 centimeters up the side. It would be a view from this direction, and we would be drawing what we can call a side elevation. Now there is one more direction that we could look at this from, a more useful direction. So if we take our cuboid again, we have already looked at it from this face here and from the perspective of this face here. We could also look at it from above. We could look down on it as if we are standing over it, in which case we would once again see another rectangle. This time the rectangle would be 5 across and 3 up this side, because we've got 5 and 3. The height of 4 we would not see because we're looking down from directly above it, a bird's eye view if you wish. And we could sketch that as well. So if we were to look at the shape from above, we would see a rectangle, 5 wide, 3 in height, and we will be looking from this direction, straight down from above, and we would be looking at, well, front elevation, side elevation. Surely it makes sense that it will be a top elevation? No, because this is maths and nothing's ever that simple. We would be looking at what's called a plan of the shape. The plan is simply a top-down view. So you could be given a diagram of a shape and asked to draw any or all of the plan, the front elevation, or the side elevation of that 3D shape. So the front elevation is the face that's there at the front of the prism, flat on the page. The side elevation is the one that's looking from the right hand side, it's the one that's disappearing back into the page, and the plan, the view down from the top. Draw the front elevation, side elevation and plan of the triangular prism. It's a little bit more tricky this time, but we are still drawing the same 3 things. We could do the front elevation first, because the front elevation is usually the easiest one to draw. It's the one that's there flat on the page. The front elevation would be this direction here. It would simply be this triangle. How wide is the triangle? Well, the triangle is 4 centimeters wide. And how tall is the triangle? We should probably put that height in. That will be 6 centimeters from the base of the triangle to the point at the top. That is then the front elevation. We could draw the side elevation as well. Now the side elevation, we might have to think about that one a little bit. Here is a triangular prism. Now this triangular prism is exactly the one that we are looking at, 4 centimeters across, 6 centimeters in height from here to here, and 10 centimeters down this side. If we were to turn this to the side and look dead on, what shape is that? Well, surely that is simply a rectangle. How wide at the base here? Well, 10 across this bottom edge. And how tall? Well, from there to there is the height of the triangular prism, the tent, the Toblerone, if you like. How tall is it? Well, it is 6 centimeters in height. Now we know from knowing this is a triangular prism that that side slopes, but we cannot see it sloping. So the height, in fact, is the base to top height of that tent, tubular and box triangular prism. So if we draw the side elevation, we are looking from this direction, and we will simply have a rectangle, 10 across the bottom and 6 up the side, and that's the side elevation. And finally we are asked to draw the plan, and we could look at this with the aid of our 3D shape again. For the plan, we are asked to look down from above, and what we would see when we look down from above, well again, we can't see if we are looking from above that that is anything other than a rectangle with a line through the middle. We only know that this is 3D sloping sides because we know it's a triangular prism. If we didn't have that information, all we would see is we would see the area on the page mapped out by that base, that rectangular base, the 4 centimeters along this edge and the 10 centimeters along this one, and we'd see this line down the middle, the ridge at the top of the tent, if you like. So all we would see would be a rectangle 10 centimeters by 4 centimeters with a line down the middle for that ridge at the center, and that would be the plan looking down from above.